What if observing something could change reality? Hold on. In quantum physics, observation doesn't mean just looking. It means interacting with the system. It's like checking if a soft cake is cooked by poking it with a toothpick. A famous example is a double-slit experiment. When a laser shoots photons through two slits, we expect to see two strips. Instead, it creates an interference pattern on a screen, caused by light acting like a wave. But when scientists used a single photon detector to see which slit each photon passed through, the interference pattern vanished, and two strips appeared. This demonstrates a core principle of quantum mechanics. Light and matter have both wave and particle behavior, but they can't be observed at the same time. In 1927, Albert Einstein had a bright idea. A photon would nudge the slit it passes through, like a bird brushing past a leaf. If we measured that photon's path and observed the interference pattern, we could see light's wave and particle behavior at the same time. But he was wrong. Fast forward to 2025, MIT researchers revisited the double-slit experiment and used 10,000 super-cold atoms in a lattice held by lasers. Each atom was isolated, making photon behavior easier to detect. They used a weak light beam, allowing a single photon to scatter off two nearby atoms to determine whether the photons behaved like waves or particles. This was just like the original experiment, where the light passed through two slits. Researchers could tune each atom's fuzziness, how precisely its position was defined, by adjusting the laser's grip. Fuzzier atoms could record the photon's path the best, making the photon act more like a particle. But when atoms were tighter, it recorded less information about the photon's path and acted more like a wave. With observation and control, researchers could show either the wave or particle behavior, but never both at once. These discoveries may revolutionize our future. And that's reality.